All right, so we're going to talk about exponential functions. What I mean by exponential functions is when you have something like y equals a times the quantity of b raised to the x. Right, so when we're given something in this form, we're going to be given a and b. We're going to be given a and b, and we're going to have to evaluate or solve for x, or at least evaluate what it looks like when we have something raised to the x. Okay, so let's talk about how a and b and x change the output of my function. This is the input of my function, which would be x, and then y is the output of my function. Okay, so the a is the starting point. The starting point of whatever I'm going to be comparing my x, my y to, right? It is the initial amount, right? The initial amount. Okay, and then b is the growth factor, right? This is the growth factor, and if b is a greater than 1, this is a growth. It means that as x gets bigger, y will get bigger. Okay, and as if b is less than 1, this is a decay, which means it's going to get smaller and smaller and smaller and smaller as x approaches infinity. Y is going to approach 0. ROA approaches 0. Okay, and in this case, our 0 is called an asymptote. Asymptote. ASYTSNTOPE, asymptote. That is asymptote. All right, so what is an asymptote? Well, an asymptote is a line that a value gets continuously closer to. It's going to get infinitely closer to this, but it'll never actually reach it. Okay, so let's take a look at what I mean by this, right? So if I have a y and an x-axis, all right, this is my x and this is my y, a decay, right? So if my b value is less than 1, it's going to look something like this, right? Where my x-axis is my asymptote, meaning that, let me kind of get a better idea, meaning that this is going to get closer and closer and closer and closer and closer and closer to x without ever actually approaching x. So as x goes infinity that way, y gets infinitely closer to 0. Okay, and then in a growth equation, right, it starts off like almost negative, and then it goes up to infinity, right? So as x becomes smaller, it approaches, y approaches 0. So this is where my asymptote is at x equals, or y equals 0. Okay, so let's go through, some more examples to swerve away a little bit from the anecdotal stuff. Okay, so here I have this equation. It's a equals the quantity of b to the x. And remember that a is my initial amount and b is my growth factor. So if whatever is in my parentheses, right, ends up being less than 1, it's going to decay. It's going to get smaller and smaller and smaller. And if b is between, 0, 1, I misread that, is greater than 1, but if it's less than 1 but equal to 0, so it's between 0 and 1, this is going to be a decay. Okay, so here's something like this, right? We can kind of look here and see that if I had an x and a y, right, and at -1, my y is way up here at 12. Okay, and then at 0, it's like at 4. At 1, it's like at, this is 1, it's just like a little bit over 1. At 2, it's like a little bit closer to this asymptote. It's just under a half, or just over a half. It's like right here. At 3, it's like even closer to 0, right? So this is getting closer and closer and closer to 0, right, as x goes up. So this is a decay, because as x goes up, y gets infinitely closer to 0. Okay. So here, this could be this equation, right? This is a decay, because this, my b term, is between 0 and 1. Right? So when it's between 0 and 1, it's going to be a decay. Because whenever I raise this to this number to another number, right, like a higher number, it's going to be, this term is actually going to get smaller by 11%. Okay, so there's that. So let's reach and get another example like this. This is a growth. This is a growth. Right? Because as x goes up, y, as x approaches infinity, y approaches infinity. Okay? So as x goes up, y gets bigger and bigger and bigger and bigger and bigger. Okay? And then over here, this is a growth, because my b value is greater than 1. Okay, so this one here, 2, it gets smaller, smaller. It gets bigger, 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 right? As x gets up, y gets bigger. So this is a growth. So as x goes up, y goes up. Okay, by some factor. Okay, so let's sketch a graph that represents an exponential growth. Well, you've seen it. It starts at something very small, and then it gets exponentially bigger. It just kind of takes off. But if I go to the left side of it, it gets infinitely closer to 0. Okay, and then here's a graph of exponential decay. Right, it starts off big, and then it approaches 0. And in class, I'll talk to you about off-gassing nitrogen for divers and stuff like that. In real life, this is what models. Exponential growth and decay is modeled very well by nitrogen load of divers. So we'll talk about that later. Have a great day. Hope this makes sense.